Good morning, Algebra 2. Mr. Woe here. Are you with me? Today, on this video, I'm going to look at part 2 of section 11-2, simplifying radical expressions. Again, part 1, we did number 8 and 10. In today's video, we're going to do number 12 and 14. Now, I did a little bit of changing from the last video. I think I was wasting too much video, putting too much time into the video by going over writing down everything and talking it through. So I'm going to do a little bit of changing here, see how this goes. I'm going to work the problem out in the way I would do it in class, and then talk it through, and then bring into attention anything else that needs to be covered. So let's get started. Part 2, numbers 12 and number 14. So look at number 12. Number 12, we have 3 radical factors, and we want to simplify this. Okay? First thing we want to do, is take our radical expressions, or radical factors, and write them down into rational expressions. So the 4 through to 27 is 27 to the 1/4 power. The square root of 3 is 3 to the 1/2 power. And the 6th root of 81 cubed is 81 to 3/6. All right? Now again, while we're working these problems out, again, in order for us to simplify this particular example, we've got to, in order for us to do the power to a power rule, not the power to a power rule, but to do the power times a power, we have to have the same basis here. So the first thing we're going to do is, work it out so that we get our same base. So first thing I noticed that I did in my problem here is I know 27 is a perfect cube. So I know that 3 to the 3rd is 27. So again, I just rewrote it, so 3 to the 3rd to the 1/4. And then also I took the 3/6 from the exponent of 81 and reduced it. All right, then the next thing I notice here as I move on, I know from this guy right here that I circled in red, that is the square root of 81. That gives me 9. Okay, but also I know that 9 is also a perfect square, and we can write it as 3 squared. So that's what I did in this case right here. Then the next thing I did is I applied power to a power rule. So again, I took this power and multiplied it times this power. That's where I got the 3/4. Now that we got it set up, we have a product of 3 powers. They all have the same base, so we just add together our exponents. 3/4 plus 1/2 plus 2/1. Then I went on Otis. I took those 3 fractions, and I noticed that all 3 of them have different denominators, so I have to find a common denominator, which is 4. So I have to multiply the appropriate fraction with the appropriate value to get the common denominator of 4. And then down here is what you would get, which eventually becomes 3 to the 13/4 power. All right? Now, we can simplify this further. Why? Well, anytime your numerator is greater than or equal to your denominator, we know we can simplify. So I know that 4 can go into 13 3 times with a remainder of 1/4. Again, I know we could do this. I'm just doing a little bit of sidebar here. So 13 divided by 4, so that means 4 goes into 13, in this case, 3 times with a remainder of 1. So we know that that's 3 and 1/4. So again, that's where I get the 3 to the 3rd times 3 to the 1/4. Well, I know 3 cubed is 27 because 3 times itself 3 times gives me 27. Again, we're done. Again, this part right here is a rational expression. Rewriting it in this way, we have a radical expression. So that's number 12. Hopefully that one was a very big help to you guys. Let's look at number 16, or actually number 14. Okay, number 14. We have the fourth root of 4096 x to the 6 y to the 8th. All right, so our whole goal is to simplify this. Well, where would we start? Well, the first thing I want to do is we're dealing with a fourth root. So I am going to go and take and ask myself, is 4096 a perfect fourth? Yes, it is. We did a table a while back in class. We know that the fourth root of well, actually, let me back it up. 4096 is a perfect fourth, and we know it's going to be 8 to the 4th. Okay. So again, calculator, if you need to use your calculator, again, 8 to the second power we know is 64. 8 to the third power we know is 512, and we know 8 to the fourth power is 4096. So we know that 4096 is a perfect fourth, and its principal root is 8. The next thing we did is took these three factors inside the radical and split them up into three individual radical expressions. That's called the product of radicals. Then the next thing we did is taking the radical expression and writing it as a rational expression all the way down the line. Nothing new. Denominators are your index of your radical. Numerators are the powers of your radicand. The next thing done was simplifying the fractions. So I know 4 divided by 4 is 1. 6 divided by 4 is 3/2. And 8 divided by 4 is 2. So simplify the exponents. Then the next thing, I noticed that the numerator of x to the 3/2 is greater than or equal to 2, so I can break him down. So what I did here is went to Otis, found out that x to the 3/2 is the same as x to the 2/2 times x to the 1/2. Once again, power times the power. Bases are the same, you add your exponents. So that leads us down to this next part here, is this comes from simplifying this part right here. We're almost done. Next thing we do is rewrite it down in a way they see it in algebra. Start off with your numerical coefficient. Then we go to the variables and we go in alphabetical order. So we'll go 8xy squared. And if we have a rational exponent, we generally put them in the last position. So this part right here is a rational expression. This part right here is rewritten as a radical expression. Again, thank you guys for watching these videos. Again, if you need any help, don't be afraid to ask. Message me or post a message if you need any additional help. Thanks a lot. I'm working on part 3. I'll get that out very soon. Thanks.